This is the second video of how the internet works. So today we will talk about the internet protocol. We are going to go detail about the IP. It's the IP is the shortcut of internet protocol, and probably you have already heard about the IP numbers, IP address, or something like this. So it is the internet protocol, and we will go into the details. The internet protocol as a part of how the internet works. So it is just the introduction part, internet protocol, and you can even have some courses about it, but we will just make a brief introduction, what is the internet protocol and how it is used in the internet. So we can consider internet as two concepts. So we can think about the hardware and the software part of the internet. In the hardware part, we are talking about the devices like hosts and the connections and the connectors. Sometimes we call them as switches, hubs, bridges, routers, or some devices like this. And in the software part, we are talking about the software running on these devices like the routing protocols, the internet protocols, which is the IP in fact, or the operating systems, or the applications running on these operating systems and the network layers. So today we will talk about the software part as a protocol, internet protocol, and then we will talk about what is the difference between internet protocol and the rest of the other communication protocols. And we will talk about how we consider a protocol, how we send some packages on the internet using this internet protocol. So in IP, actually the internet protocol is a protocol between two parties. So there's a sender and a receiver. So the IP deals with how this information flowing from the sender to the receiver is finding its path or delivering the information. What are the methodologies, what are the techniques for sending this information through the internet, because there are lots of traffic on the internet and there are lots of people already talking on the internet. So we need a solution for secure and routed, so from point to point communication on the internet. Actually, security is not a main part of the IP. We will talk about it on the next video when we are talking about TCP, Transport Control Protocol. But IP is one of the essential part of TCP, so it can work on IP. So today we will talk about these routing things or packaging things, or how we carry out these information from one point to other point by using these protocols. So this is just a symbolic map. I mean, you can see some hosts. You can consider these red squares as the hosts. For example, there may be a computer sharing its internet, so there are some multiple devices connecting internet through this device, or there may be some switches or hubs which multiple computers are connecting at the same time. Or you can think about a local area network in a company or a university, so multiple computers are connected to each other, and then there are some uplinks. I mean, there are some communications from this local area network to the wider area network to the internet, and there may be some multiple connections at the same time. So a communication between one point to another point requires the packages flow through the traffic through the internet. And if you have, for example, some problems in one of these connections, let's say you have a broken link in here, then the packages will find another path for passing through, and then at the end they will find their way to the destination. So IP works like this. In an IP package, so first of all, the data, for example, you can consider the video you are watching now is a data at the end. So I'm talking now, I'm streaming some video, but at the end it's the data. So this data is split into the packages, first of all, and then these packages are sent from sender to the receiver. So the first part of IP is splitting data into the packages, and then the data is transmitted with a destination. So each of these IP packages, on all of these IP packages, we have a destination IP address. So they have an address, and then they are finding their way by asking their path on the road. So for example, an IP package starting from here and heading to this way, this destination, will just go to the first hub the internet is connected through, and then will ask its path, its way, going to the destination. So it will ask for the IP address of the destination. If this host is aware of this IP address, then it will send directly to the next hop on the network. Otherwise, the hope the node that you are asking for the address, the way, will send you to the default forwarder. So there are some forwarders on the internet. So if you are not aware of the destination, you can just send to the default forwarder and ask that, I don't know the correct destination, correct path, but if you know, please redirect this message to using another path. So they are passing these messages to each other, and then they are just routed on the internet by asking their path. Sometimes if nobody is aware, maybe they will be sent somewhere else, and then the message will be dropped, because all the IP packages have a time to live on them. So if you say, for example, this message will be delivered in 1 day, let's say, and the message could not be delivered in 1 day, and if it is still trying to find its path, then this message will be deleted, because it's looking for the destination on the wrong place probably. So in order to reduce the network traffic, this message will be deleted and then will not be repeated on the internet anymore. Okay, so in the software, we are talking about the link layer. You remember we have had the physical layer just below the link layer. So we have physical layer, link layer, and then now we are talking about the network layer. In the network layer, we can talk about Internet Protocol. Internet Protocol, I mean IP, is not the only protocol in the network layer. There are some alternatives of the network protocols, like IPX, SPX. You can use some other protocols on the network layer, but IP is, I think, one of the most famous network protocol because we use it on the internet. So if you have some special networks, you can also define your own protocol, you write your own protocol to communicate computers. So there isn't any limitations for the protocols at any layer, but IP is a sample of the network protocols. And although, of course, we know the network protocol is sending data through the link layer and then the physical layer, so the network layer should be somehow communicating with the link layer. Okay, so the network layer we will talk today is sending some information. For example, you prepare an envelope and write the receiver, right where you are sending this message on an envelope, and then you send it to your friend, let's say, and you ask him or her to send it to somebody else if she or he doesn't know the destination, or if she or he knows the destination, she directly sends this message to the receiver, but otherwise she will just send it to somebody else in a random manner. So let's assume this is the case, this is the scenario, and even in this case, if let's say everybody puts a time on this envelope and then checks if the time is up or not, and if time is up, they will just drop the message to the floor, and they are passing these messages to each other. Think about this. And this is how the internet is worked, in fact. And there are some traffics for somebody, perhaps. If somebody is very famous on the class, everybody is sending these envelopes to this person, and then there's a traffic over there. He or she cannot read that much envelope at a time, so it takes for longer time to wait over there. This is called the network congestion in most of the time. So this is how the internet works. We are always sending some messages to each other with packages. So you put these messages into an envelope, you can think like this, and then writing the receiver on it, and then sending it to your best friend or the person next to you, and then you ask her or him to send to somebody else. Okay, before going to the packet switching, maybe we can talk about channel switching. So this is the early communication method. Perhaps you have seen it in old movies, or maybe you are old enough to remember these days. There was an operator. Whenever you want to make a phone call, you first call the operator and then ask her to connect you to somebody else. And what operator does was connecting a cable and plugging two ends between your plug and the destination plug. So you have a virtual circuit. I mean, there is a communication. There's a wired communication between two entities, you and your destination. And then you can make a phone call and talk with him. And then when you are done, the operator finishes this communication, and you can call her again and then request for another connection. So this is how it works. So you have a special dedicated channel between you and the destination. In the channel channel switching networks. But of course, this is also possible in the internet. There are some virtual circuiting technologies. Although they are a little bit more expensive than the packet switching, you can have some channel switching technologies for special purposes. But most of the time we use packet switching for communicating to entities. So what we do is we split data into the packages, write the destination on all the packages, and then send these packages on the internet, and we expect them to find their path through the internet until they reach to the destination. So that's how the packet switching starts. And a little bit about the history of the packet switching. So we have some heroes, some people finding these packet switching, and okay, I will just jump over something, and then let's come to this routing table or the IP addresses. So that's what I'm talking about, the time to live. If you cannot deliver a package within this given time to live, then this package is dropped, deleted. So you can think that the packages lost their ways, are not creating a network traffic, they are not creating any problem on the internet, because they have a time to live, and after a while they will be dropped on the internet. And we also have a routing table. So if you have a routing table like this, you can think about a routing table like the person you are asking for your way, for the best path to the destination, and you have a destination IP address written on your envelope or your package, and then you are asking for the destination. And if this routing table is aware of the destination, for example, it's checking for the first two numbers, and then the rest is left as, let's say, joker card, wild card. So if you can fit these two first numbers, and then you are just forwarded to this IP address. That means the address starting with these two numbers will be forwarded using these IP address. So there's a router over there, or there's another gateway over there, which is aware of the exact destination you are asking for. So the package comes to this router with the destination information will be forwarded to this IP address for their arrival. On the other hand, the other IP addresses can be listed here. Any IP address which fits in these wildcards means that this router is aware of this destination. Otherwise, there is a default forwarder which you can consider XXXX 4X. So which means you don't fit on any of these addresses, which means you will be forwarded to the default forwarder for any cases if you don't fit in here. So you are just forwarding to somebody else, and you hope this somebody else will take care of this IP address or aware of this IP address, so it will be delivered. So that's how it works. And the IP address is actually a binary number. It's starting, it has the length of the IP address is 4 bytes. So 4 bytes means, each byte is 8 bits, so 4 bytes is 32 bits in the length. So the IP address will be 32-bit length binary number. But in order to read it easily, for the readability issue, we just convert them to the decimal numbers. So here you can see an 8-bit information, like starting from 0 to going up to 255. So it can be any number, any decimal number between these two numbers. And you have 4 numbers, which is representing 1 byte, which is representing 8 bits in the IP address. So you can think like this is the first octet, the first byte of the IP address. This is the second, third, and the fourth octets, or the binary numbers, 8-bit binary numbers of the IP address. So that's how an IP address is considered. Actually, this is called as IP version 4. We have IP version 6, which is a newer version. It is not officially used in the whole internet, but people are moving to IP version 6 slowly, and the new devices supporting both IP version 4 and 6 at the same time. So there will be a launch day that everybody will switch to IP version 6. In the IP version 6, instead of 4 octets, 4 bytes, we have 6 bytes. So that's where the version 4 and version 6 comes from. In IP version 4, we have 4 bytes, so it is called as IP version 4. In IP version 6, we have 6 bytes. That's why we call it as IP version 6. And then in the IP version 6, the reason of IP version 6 is the number of IP version 4, the number of IP addresses is limited. So we already reached this limit and we exceeded this limit. So we are looking for better addressing in the IP version 6. Actually, we will talk about it later on, but let's talk about a little bit about the history of the IP versions, IP addresses. So it starts as a military project in DARPA, So actually there were 4 universities, the universities involved in this project, and you see some of these universities started as a 4-node. So this is the first internet started on the US, on the military. And then ARPANET is another project. And then in 80s, higher education is involved in this project. So originally the network is between the military bases, military projects, military entities, let's say. But in 80s, the higher educations joined in it. So it boomed after people joined internet using the higher education networks. In 1990s, commercial enterprises also involved into the internet. They have their own hostings or other equipments, so you can connect to the internet. And also it got worldwide in 1990s. The number of connections boomed suddenly in 1990s. In 1980s, there were some initial, there are some basic and simple connections between the countries around the world, but in 1990s it boomed with the communication. So it became somehow personal. I mean, in 1968, this is the first modem. Modem is stands for modulator, demodulator, and it's a personal device for connecting to the internet. In 1980s, we had these personal communication devices that you can use your computer and modem to connect to the internet. But in 1990s, this has a wider use, and people were connecting to the internet by their home computers, personal computers from their homes. So that's why in 1990s it boomed. And let's go for the address activity. We already talked about this 4-byte IP, and the limit is roughly about 4 billion different addresses. So we already reached this number. So consider all the smartphones, all the tablets, all the cellular networks connecting your devices, all the university computers, all the servers that you can connect, almost all the, for example, a single company may hold let's say thousands of servers for different purposes or for just load balancing around the world. So the number is already exceeded. In Smith College we have 65,000 IP addresses, and of course we reached this limit. So let me give you a brief information. What is an IP address and what can we do about the IP addresses? So first, I can start with ifconfig. So I'm using an OS X box, so it's a Macintosh MacBook. Actually, the commands are very similar in Linux and Unix, so you can use the exact same command in Linux and Unix environment. And in Windows machines, instead of ipconfig, you can go for ipconfig. So it is like Internet Protocol config, but in ifconfig, we are talking about interface config, but it's similar at the end. So these are the interfaces I have in my computer, in my MacBook. So this is the active interface. I know it because it is called as Ethernet 0. It is actually the Wi-Fi wireless communication from my computer to the Wi-Fi hotspot. But you can see there is an iNet address in here, which means this is the IP address that I'm communicating with my hotspot. So this hotspot or the DHCP server, I will go into these details, don't worry about it. This IP address is automatically assigned to my computer. So any action I do with my computer is considered, all the packages coming from my computer is considered as the source IP address in here. Okay, so you put this source IP address as the address, and any package coming to my computer has the destination IP address like this. Okay, so this is IP version 4, and just above it you can see the IP version 6 in here. So instead of using decimal numbers, now we are using hexadecimal numbers, and then you can see the details over here. And ifconfig is a way of learning your IP address. On the other hand, you can use something like traceroute. So if I go for example, traceroute, and in Windows machines, you simply write trace RT instead of traceroute. In a longer form, you have a shorter version in the Windows machines. Or if you have Unix, Linux, BSD, or OS X computers, then you can use traceroute. And then you can give a name, let's say Smith, CS Smith edu. So that's how it works. So first, this Smith edu is converted into an IP address because, okay, we can understand these names. These names are meaningful for us, human beings, but computers do not understand the names. They only understand the numbers. So the first thing is converting this name into an IP address. So you see the equivalent IP address of this name. So another way of converting is NSLOOKUP. So you can go for NSLOOKUP and write, let's say, something like Simit edu, and then you see there's a conversion from this name server. Actually, this is the name server I'm using now, and the equivalence of this Simit edu is this IP address. So you can make a conversion from an IP address to name or name to IP address. So we get this IP address in here. So we can, for example, use, let me use exit to exit from this NSLOOKUP tool. And then I will go for trace route for the given IP address. It's exactly, oops, I have a misspelling here, I think, typo in here. Again, I have a typo in here, trace route, and then the IP address, okay? So now it's sending some packages to the destination, and trace route is a tool for understanding the hops your packages are passing through. So if you, for example, send from a source to the destination, of course you don't have a direct communication between them most of the time. You have some other computers, some other routers, some other servers between you and your destination. So each time your package passes from a node, this node is written in here. But I think we don't have a bounce back option in here, so I will go for a little bit. So how do you stop it? By the way, if you want to use it, you can simply use Ctrl and C from your computer, your keyboard, and it cuts the running of the current command. So I will go for a little bit more famous destination trace route, let's say google.com. And then it works now. You see, these are the hops my packages are passing through. So you see the next package, the package is passing from, okay, we connect, the Simit edu is connected through the UMass edu, probably the package is jumping over there. So that's how it works. And finally, it's reaching the destination here. There may be some delays on some nodes. And then finally, the destination is here. The package is jumped over, let's say, 11 hops. So you can see where the package is traveling on the internet. Okay, so this is the IP address availability, and the IP version 4 is ending. The number of IP version 4s we are using is ending, so we need a solution. The first solution is using DHCP servers. So here, domain host, dynamic host configuration protocol is a server assigning some local IP addresses which are not valid on the internet. Okay, so in the internet you have a unique IP address, because otherwise the destination and source will be mixed. I mean, there will be a confusion about it, because if somebody sends to a destination IP address and writes this information on the package, and if the receiver has, I mean, if you have two receivers with the same IP address, then there will be a confusion. This package will be delivered which of them. So this is called as IP conflict. And if you have IP conflict, you need to fix it. Otherwise, these devices will have problems to receive and send some information on the internet. So on the internet, we have a unique IP address for each of the devices if it is directly connected to the internet. But what we have in the DHCP server is, instead of using this unique IP address for all the hosts connected to the internet, we go forward and we assign some local IP addresses. We can also call them as dummy IP addresses, which is not valid on the internet, but it is valid in the local area network. So whenever a computer behind a DHCP server or gateway, we can sometimes call it as a gateway or NAT server, NAT server. Whenever you have a communication request from a computer behind this gateway, this computer connects directly to the gateway, and the packages passes through the internet by using the IP address of the gateway. So gateway uses its IP address, shares its IP address for all the computers behind the gateway. So whenever a computer wants to connect to a destination on the internet, the packages are traveling from here to the destination by using the real IP address of the gateway. And you may ask that there might be a confusion if there are some packages coming to this IP address, but how can we understand which computer is the destination? Because you can have multiple computers behind this IP address. So the solution is keeping them on a table. So this DHCP server is keeping a special table for all the local IP addresses and the IP addresses they are sending through. And we have a port technology, by the way. On the server, you can have some port numbers which is limited with a certain number of cores, and then it's keeping these port numbers for the communication. So these port numbers, we will come on them on the TCP layer afterwards, but for now we can talk about the DHCP and NAT server. So in the DHCP we have a local inward face IP and an outward face IP, which is a global IP address, which is a valid internet IP address, and there is a conversion between these real IP address to the local IP address. So this is one of the solutions. Instead of limiting the number of computers connected to the internet, for example, you can get a single IP address for your company, and then you can connect multiple computers, let's say thousands of computers, by using a single IP address. So that's a way of increasing the number of connected devices to the internet. And another way of increasing the numbers is IP version 6, which is a newer version of IP. Instead of using 4 bytes, 4 octets, we are using 6 bytes as the IP address, and it's a better way of communicating to the, increasing the number of devices connected to the internet. So the number booms from 2 to the power of 32, and it booms to the 2 to the power of 48, which is a quite bigger number than the previous IP version 4. So that's all for now. This is just an introduction to the IP Internet Protocol, and then we will keep going on with the newer topics in the next videos. See you.